Hello everyone, Quentin here with Eagle 3D Streaming. We have a great video for you today. In this video, we're going to show you how to open ports for multiplayer. Let's jump right into it. Now that we're comfortable with running a dedicated server and 2 instances of Unreal on a single machine, we are going to take it a step further so that we can now run multiplayer on multiple machines, meaning we'll have the Unreal Engine application running on separate machines, and then we'll have the dedicated server running on its own individual machine. In order for us to do this, we're going to need 3 total PCs. The first PC is going to be for the dedicated server, and the second 2 PCs are going to be the PCs where you will be playing your Unreal Engine application. These PCs could be any gaming PC with an NVIDIA GPU and drivers. With the dedicated server PC, it's a little different. Now, if you remember from the first tutorial when we ran it locally, there actually is not any graphics rendering when you run the dedicated server. So the dedicated server PC could be, you don't really need a graphics card for this dedicated server. It's actually, you really only need CPU and RAM in order to run the dedicated server. So you don't need a gaming PC to run this, which should be a sigh of relief. You can use a much lighter machine. In this example that I'm going to show you how we're going to play multiplayer over the internet, I'm going to set up my dedicated server in AWS, and there's reasons for that. Of all the clouds that Eagle has tested, we found that AWS is the best for dedicated servers. We've tried on Azure and other clouds, and we always run into issues, but with AWS, it's the cleanest and most reliable. That means that I'm going to then take you step by step through the process of picking your dedicated server and setting it up, getting all the port stuff correct so that you can use your dedicated server in AWS for multiplayer pixel streaming over the internet. The first thing we need to do, if you're new to AWS, is we need to pick out our dedicated server. And if you remember, we don't really need a GPU for the dedicated server because it's not rendering graphics, it's just orchestrating between your instances of Unreal. That means that we can use a much lighter instance in AWS, and I like the T3 instances. I'll provide this URL in the description of the YouTube video. Once we're at this page, let's go down and look at our choices. We have a nano, micro, small, medium, large, X large, 2X large. Now, depending on how many users you have connected to your dedicated server, the CPU or compute is going to increase. Typically, what I like to do is to start with the T3 large, which has 2 vCPU cores and 8 gigs of memory. This is a good starting point, and you can then test to see how many concurrent users you can have attached to your dedicated server. And if you need more, you can just keep bumping up and you will be able to add additional users. For this example, we're going to start with the T3 large because it's a good starting point. Now that we have selected our instance, let's go ahead and start setting it up on AWS. The first thing you'll need to do is to sign into your AWS console. And if you're new to AWS, go ahead and create your account, and when you first sign in, you should see something similar to this. We will have to create the instance of our dedicated server, but before we do that, I do want to check and make sure we have the necessary quota in order to create the instance. The way AWS works with a lot of the clouds is you can't just create any virtual machine that you want because they're trying to make sure that, I don't accidentally create 1 million dedicated servers. And so the way that this cloud and all clouds that I know of police this is by limiting your quota on how many virtual machines you can create. That means that we do need to just quickly check and make sure that we have the proper quota. I move my mouse over to the search bar and I type in quota. and then I go to service quotas. On this page, I'll go over to manage quotas and I'll type in EC2. And if you're wondering why EC2, this is the term that AWS uses for their virtual machines. So let's select Amazon EC2 and then click View Quotas. And you're going to see that there are tons of pages associated with this. In order to make this super easy, I will provide this shortcut, but we just need to type in running on demand standard, and then we'll be able to see our quota. Here I can see that our quota is 512. And if the next question could be, well, how much quota do I need? It will depend on how many vCPU cores you would like. If you're going to start with the T3 large, which is what we're going to do, then you will need 2 vCPU cores. I check my quota list and I can see I clearly have more than 2 vCPU cores. I have 512, so I'm good. But if you wanted to create, I don't know, T3 2x large and you wanted 10 of them, or I guess you would need, I don't know, 100 of them to get over that limit, let's say 100, then you would have to make a capacity request because it would be 8 times 100. So you would need 800 total vCPU cores, and I only have 512, which means that I would then need to make a request for this. And the reason why I am searching for this is because you can see that it includes the T instance. And if we go here and double check, we are indeed checking out the T type instances. So that's how AWS organizes their instance types, by letters. We're using a T instance. That's why we're checking our quota for the T instance. If you run into a situation where you do not have the proper quota, just click request increase, specify the quota request, and then follow the prompts through. Usually it's pretty easy to get quota for the T instance. The other thing that you need to keep in mind is you need to make sure that you're getting this quota in the proper region. Now, if you've played multiplayer games like me, one of the things that you always look for is the multiplayer server closest to you. And now it may start to make sense why that is because the closer the server to you, then the lower the latency will be. In AWS, like a lot of clouds, they have regions all over the world. Make sure that you request capacity in the proper region by clicking the drop down and selecting the region that you would like your dedicated server in, to make sure that you request quota in that region. Because if you request quota in the wrong region, then when you try to create a server in Frankfurt, but I have quota in Ohio, then I won't be able to create my instance. All that to say, make sure that when you're checking your quota and you're requesting quota, that you have the region that you would like for your multiplayer server to be in selected in this top right. Okay, now that we know that we have the right quota, it's time to go ahead and create our instance. We'll do that by starting at the home screen and then clicking on EC2. Once I've clicked on EC2, the next thing I will do is I will click Launch Instance. When I'm at this page, I can begin setting up my multiplayer server. The first thing I'm going to do is to give my multiplayer server a name. Next, I need to pick the machine image. Since we are going to run this on Windows, I will select Windows, and then I need to select my operating system. Typically, I go with 2022 base, but you could also do 2019 or 2016, but always make sure you pick base and not core base. I will select 2022 base, and then I need to pick my instance type. I click the drop down and type in T3, because if you recall, we are going to be using the T3.large instance. So I type T3 to get more specific results, and then I scroll down until I find the T3.large, and I left click to select it. The next thing I'm going to do is to create a key pair. The key pair is very important because this is how you're going to remote desktop into your multiplayer server. It's important after you create your key pair that you keep it in a safe place and do not lose it, because you only get one chance to create your key pair, and that's right here when you're creating your multiplayer server. Make sure you keep it in a safe place, because if it's lost, then you'll have to terminate your instance and create a new one because you won't be able to remote into it. You can use an existing key pair if you have one created, but let's create one from scratch so that you have all the details. I go hover over create new key pair and left click, and then I will give my key pair a name, my multiplayer server key pair. Once I've given it a name, I select RSA for the key pair type and .pim for the private key file format. Once I confirm I have my name, my pair type, and file format, then I click Create Key Pair. You'll notice that my key pair will be downloaded into the download section of my browser. Once you see that it's downloaded, then take that file and put it in a safe place to make sure that you have it, because we will definitely need this later for you to remote into your multiplayer server. Next, I go to network settings. In this instance, you could create an existing security group or you could create your network settings from an existing security group if you have it. However, similar to the key pair, let's create one from scratch so we go through the entire process. For now, I'm just going to select Create Security Group and then click Edit, and let's give the security group a name. So I'll call it my multiplayer server security group. And I'll also mirror that in the description. The porting is probably the most important part of this process, but I'm not going to do it right now. We'll do it after the security group is created, and you'll see why later. For now, you can keep these settings as default, and once we create our multiplayer server, we'll come back and finish out the networking information. Lastly, determine the storage you would like for your multiplayer server. I'm going to do 60 just to make sure I have enough room for my dedicated server, but you could do a lower number depending on how. The second place that you can sometimes get tripped up is I'm going to right click on this instance and click Stop Instance, and then stop. And you can see now that the instance state is stopping. Now you'll also notice that I have this flag right here which is filtering for only running instances. If I remove that, and then let's go back to the home screen, click on EC2, and then click on instances running, you'll see that it looks like I actually don't have any instances running. But that's not true. It's actually just this flag is filtering for only running instances. So if you see this and you're certain that you have an instance there, then double check to see if this is active or not. Just left click it to delete it, and then select your instance, which is right here, and then right click on it and start it. And I'll go ahead and go back to the home screen and go back so that we can see just that instance. One last thing to note before we move on to porting is whenever this instance is running, you will be charged by AWS. If we look at their pricing, you can see it right here for on demand. For the T3 large, it's about 8 cents an hour, or 9 cents, maybe closer to 10 cents when you include the operating system and storage. Just keep that in mind when you are working with your multiplayer setup, that whenever this instance is running, you will be charged. Only have this running when you're actually using it for multiplayer gameplay, and then whenever you're finished, please be sure to turn it off. Okay, now that we've gone through the hangups, let's configure the porting, and this is one of the most important steps of this process so that we can use your multiplayer server for multiplayer. Let's start at this page where I can see my EC2 instance, and then let's navigate over here to this left column to security groups. I will left click on security groups, and then I will find the security group I created. You'll have to keep in mind and remember the name of your security group. That's why I always label everything my multiplayer server and then dash and then the type after that so that I can keep everything organized. Click on the security group ID. I see the inbound and the outbound roles. What we're going to do here is to allow all TCP, UDP, and all traffic on both inbound and outbound. Now, of course, this is just for a demo, and you'll have to discuss with your IT team for the proper network config, but this is just to get you up and running as fast as possible. Let's do the inbound rules first. I select inbound rules, then I go to edit inbound rules, which takes me to a new screen where I can begin adding the configuration. The first thing that we're going to do is to allow all TCP traffic on anywhere-IPv4. I'm also going to delete RDP. If you're wondering why, well, we're now allowing all traffic on all ports, and I don't want this rule conflicting with the other rules I'm going to create. So let's go ahead and delete this RDP rule. After I have allowed all TCP on IPv4, let's add a rule. All UDP anywhere-IPv4. Let's add another rule. All TCP anywhere-IPv6. So you can see the difference now. These first two rules are all TCP and UDP on the IPv4 protocol, and now we're just doing the same thing for the v6 protocol. I have all TCP for the v6 protocol, so let's now do all UDP by clicking add rule, all UDP anywhere-IPv6, and let's add two more rules, all traffic anywhere-IPv4, and let's add one more rule, all traffic anywhere-IPv6. So you should have a total of 6 rules that allow all traffic on both TCP, UDP, and all traffic, and you have deleted your RDP rule that comes as a default when you create your security group. So you should just have 6 here. Once I've confirmed this, I'll click Save. And the inbound rules are now complete. Let's now do the same for the outbound rules. I first click on outbound rules, and you can see that I already have all traffic enabled for IPv4. The other thing that I'm going to do is also allow all traffic for IPv6. I do that by clicking on Edit Outbound Rules, then click on Add Rule, All Traffic, Anywhere -IPv4, and I'm going to go ahead and change this to anywhere-IP. So this one's anywhere-IPv4, and this one is anywhere-IPv6. So now I've allowed all traffic on both v4 and v6. Once I've confirmed I have 2 rules and I'm allowing both on v4 and v6, I click Save Rules, and now you can see the final configuration. On outbound, it's all traffic for v4 and v6. On inbound, it's all traffic from TCP and UDP. The next thing that we need to do before we remote into our instance is to set up our elastic IP. By default, Amazon does not assign a persistent static IP address to your EC2 instance. Therefore, we need to do this by using what AWS calls elastic IPs. Through an elastic IP, we will assign an IP address to your EC2 instance that will persist as long as you have the elastic IP assigned to that EC2 instance. If this step is skipped, then you'll run into trouble because the IP address of the EC2 instance may actually change over time when you turn and turn off the PC. And if you recall, the way that we communicate with your dedicated server is the IP address. So we want to make sure that the address is always the same so that we can always connect to your dedicated server through the same IP address. It will make things much easier so you're not having to constantly check to see what the IP address is and then using that IP to connect. To set up my elastic IP, I go to Network and Security and click on Elastic IPs. Make sure that you're in the proper region where your EC2 instance is. Once I've confirmed my region, I will click on Allocate Elastic IPs, and then I will go to Amazon's pool of IPv4 addresses, which looks correct, and then this is fine and this is fine. I'll click Allocate. Now I have created my elastic IP. Once I've created it, I receive a message that it has been created successfully, and I see the name of the elastic IP address. Next I need to associate this elastic IP address, and I could click this, but let's assume that, for example, you forget, or you come back to the screen, or you just simply don't have this green screen. Here's a way to do it to always make sure you can associate it. I first select the elastic IP address that I would like to associate, and when I say associate, all I'm doing is I'm just going to pair it with my multiplayer server, which I sometimes call the EC2 instance because that's the name of the servers that Amazon calls. When I say associate, I'm just going to attach it so that that IP address is always connected to my multiplayer server. I select the IP address, I click Actions, and then I go to Associate Elastic IP Address. I confirm I have the proper elastic IP. Resource type, I'll select Instance, and then we will choose my multiplayer server instance. I will select that. For private IP address, I leave this blank. And for reassociation, I also leave this blank. So I have instance and then the name of the instance. These two are blank. Once I've confirmed this, I click associate. Now I have associated my Elastic IP with my multiplayer server, and we can see the instance ID, which is the name of the EC2 instance for my multiplayer server right here. And if I click on it, then I can see that that instance ID is, of course, corresponds with my multiplayer server. And then I can also check over here, and I know that I have my Elastic IP associated. The next thing we need to do is now remote into, now that we have everything set up, let's remote into this multiplayer server and set it up for multiplayer. Since I did just associate Elastic IP, one thing that I like to do is to reboot the instance just to make sure everything's properly configured with it. I'm going to reboot it, and then once it begins, or once it is again running, then I will resume and we will remote into the instance. After I rebooted my instance, I went ahead and also stopped the instance to show another important point for those new to AWS. For all of your servers, you can either have them stopped, which means they're not running, or you can have them running by starting the instance. This is important for two reasons. The first reason is AWS will charge you whenever the instance is running. So please be sure to make sure you're only running the instance when you want it running. And another important thing is sometimes if it's in the stopped position and I go to EC2 and then I click on instances in the correct region, you may not see it and you may not think that you have your multiplayer server. Sometimes Amazon does this where it just shows instance state is running, so it's only going to show me my running instances. If I close this, then I will see my instance right here. I'm sharing this just because so it doesn't trip you up if you actually don't see your instance. Double check to make sure that you're in the right region and that you don't have that flag, which will filter by only running instances. Now that I have selected my appropriate multiplayer instance, let's go ahead and remote into it. The first thing I'll do is start the instance, and it'll take maybe about 1 minute to start up. When my instance is finally running, I can click the refresh button and I should see the 2 of 2 checks passed, which means that it's now time to remote in. I select the multiplayer server and I click connect. I go to RDP client, then download remote desktop file. This is going to download the remote desktop file for my multiplayer server. The next thing that I need is my password, and this is why I mentioned it's important to keep your key pair, because now this is where we'll use it to get our password. Click on password, get password, and then click on upload private key file. Select your .pim key, and this was the key pair that I mentioned to create when we were creating our instance, and hopefully you kept it in a safe place because now this is how we'll create our password. Select that .pim file and click decrypt password. This will produce the password that you will use to remote into your instance. The last thing that we need is the username that we will use to remote in, and that for me is administrator. Now that I have all this information, I can now remote into my instance. I will go ahead and go to where the RDP file is that I downloaded. So when I click download remote desktop file, usually this goes to the downloads section of your browser. Find this RDP file and click it. And again, make sure that your EC2 instance is running. If it's not running, then it will say it'll fail to connect. Once I double click on the RDP file, I will see this screen, and then I will click connect, and then I will see this screen. I will copy the password and paste it right here, and then I click remember me, and again make sure your instance is running, and then I click OK. I'll then see this screen. I usually check this box and then say yes. I double click on the dedicated server shortcut, and we now see that we have our black screen running, which gives us the log and confirms to us that the multiplayer server is running. We've made a lot of good progress, and we have all of our networking and port information set up. We now have our dedicated server running. The next step is to connect to this dedicated server over the internet. And that's the end of today's video. Thank you guys for watching till the end. I will see you all in another future video. Until then, take care.
Upload your first Unreal Engine project on our Pixel streaming platform for free. To create an account, go to account.eagle3dstreaming.com/sign up and get a free 7 days trial. Eagle 3D Streaming, it's just easier.